Alrighty, this video is going to go over the how to balance various chemical equations. Hopefully you learned a little bit something in our last PhET activity online. Hopefully this is just kind of review of what you've already learned. But if you are still confused, make sure to reach out for help. So steps for balancing. When we're balancing equations, you're going to break each molecule into its individual atoms first. So we're going to be dealing with chemical reactions, so a whole formula, which we've already learned about naming. Your first step is going to be to break each molecule into individual atoms. So if you had H2O, for instance, as your molecule or your compound, you're going to break it into H and you're going to break it into O. So hydrogens and oxygens. After you're going to do that, you're going to count the total amount of each atom on both sides. You're going to compare your reactants to your products. And then you're going to alter the amount of each molecule until the total number of atoms is equal. So this is where it gets a little bit fun. I personally love balancing, but it can get tricky as well. So let's say we're looking at this example. C2H4 plus 3O2 yields 2CO2 plus 2H2O. So we're going to use this just as an example of what a balanced equation might look like. I am going to copy this onto another screen because otherwise my words are going to go away, so give me one moment. Okay, so here's our compound. So what our first thing is going to do is we're going to just draw a line down the middle. Why isn't my marker working? There we go. Draw a line down the middle, and we have carbon here because we have a C. We have hydrogen, and we have oxygen on this side. On this side, we also have carbon, oxygen, and hydrogen. What I am going to do really quick actually is make sure these are in the same order. Alrighty. Carbon, hydrogen, and oxygen. So, like I said, your first step is to just denote how many of each compound are on each side. So on this left side, on our reactant side, we have 2 carbons here. We have 4 hydrogens, and oxygens, we have 2 oxygens here. But notice we have this coefficient out front, this 3 out front. We learned last semester that 3 is important. It's telling us that we have 3 copies of the O2, as you can see down here. So we don't just have 2 oxygens, we actually have 6, since we have 3 copies of those O2s. So this is how many we have of each on our reactant side. On our product side, we have 2 CO2s, so we actually have 2 carbons. We have 4 oxygens, and then we have 4 hydrogens. But notice we have another oxygen right here, and this 2 tells us we have 2 more, so we actually have 6 total oxygens here. Our goal of balancing is to make sure that we have the same amount of products as we have the same amount of reactants. We learned first semester about the conservation of mass. Does anybody remember what that conservation of mass states? It states that mass cannot be created or destroyed, so we can't just make elements out of nothing, and we can't make them disappear. So we need to start with the same amount of atoms as we end with. So we start with 2 carbon atoms, and we end with 2 carbon atoms. We start with 4 hydrogens, we end with 4 hydrogens. We start with 6 oxygens and we ended with 6 oxygens. So this is a balanced equation. This is the goal of what we're going to try to accomplish. So let's try another one together. KClO3 yields KCl plus O2. So let's draw that line down the middle again. Oh, my line's not appearing. There we go. And first, let's denote what we have on each side. So we have K, potassium. We have Cl. Notice this is Cl, not Ci. And we have oxygen. And we should have the same things on the other side. Again, we have potassium, chlorine, and oxygen. Our next step is to figure out how much we have of each. Here we have 1 potassium, 1 chlorine, and 3 oxygens. And then on this side we again have 1 potassium, 1 chlorine, and we have 2 oxygens. So let's check if we're happy. We have 1 potassium to 1 potassium, which is good. 1 chlorine to 1 chlorine, but we have 3 oxygens to 2 oxygens. So we have to do something about our oxygens. And what we can do when we're balancing is we can add coefficients, which add extra copies of oxygens. So just like we did with our boxing method of naming compounds, we have to add more packages. So what if we add another package of O2? We know there's at least one, so we can add another package. When we put this 2 out front, it's going to change the number of total oxygens we have. So now we don't have 2 oxygens, we have 4. So now we have too many oxygens on this side and not enough over here. So something we can do is add a coefficient out front here. But notice if I put a coefficient in front of our reactants here, it doesn't just alter our oxygens, it's altering everything in this compound. So now I have 2 potassiums because this 2 distributes to everything. Okay, I now have 2 chlorines and I have 6 oxygens. Here, I now don't have anything equal. Everything's now a mess, so I need to add more coefficients. So maybe I'll put a 2 here to give myself 2 potassiums and 2 chlorines. But my oxygens still aren't happy, so maybe I can get rid of this 2. Oh no, that's not what I wanted. How do I just get rid of that? I think I can just get rid of this here. Well, that kind of worked. Okay, so I can get rid of that 2 and I can bump it up to a 3, and then I have 3 copies of the O2 giving me 6 total oxygens. And now everything is happy. Sometimes these might take you a little bit to solve. Okay, you need to take your time. Make sure you're going slow and solving these problems carefully. If this balancing thing still doesn't make sense to you, make sure you visit that other complementary or other supplementary video I posted below. Otherwise, make sure if you reach out if you have any questions. Thank you.